Hello dear students, my name is Vikram Nalode, Assistant Professor in the Department of Mechanical Engineering working at SATCOE, Yadra Isulkanji. In last lecture we started different arrangement of the cylinder in the engines, so that part we will repeat from where it was remaining. So let's discuss about the remaining part. So last time we discussed the objectives and arrangement of the engine cylinder, that is the content part. So in objective we have to study and understand different arrangements of cylinders of automobiles. So in previous lecture we had already classified up to 4 cylinder engines. So the remaining part we will cover. So I will skip some of the slides fastly. Single cylinder engines has been covered. 2 cylinders engine and the types, inline type placed side by side and 180 degrees out of phase and 270 degrees. These are covered, and then V type of 2 cylinder engine. In previous lecture this diagram was not present, but here it is clearly mentioning about horizontally opposed type. So this is the 2 cylinder engine in which in these cylinders are kept exactly opposite to each other, but centrally crankshaft where both the pistons are connected with the help of the connecting rod. So the disadvantage of this horizontally opposed type is only that the length of the engine increases too much. So other parts we have already discussed, that the power generation takes place at 2 revolution of the crankshaft, that is 360 degrees. Okay, 3 cylinder engines we have covered. So basic thing I will tell that this is the engine block carrying 3 cylinders. So this jiffy shows that how pistons move inside the cylinder by the movement of the crankshaft. So next, up to this we had covered that there are 4 cylinder engines type inline, V type, horizontally opposed. So in inline you see that all the 4 cylinders are parallel to each other. In V type arrangement it has some angle in between the two different sides of the cylinder. And thirdly, horizontally opposed uh, 4 cylinder. So you just observe that this is the crankshaft. When it rotates it gives power to the parallelly opposed directional pistons. So in this side 4 cylinders are present, this side 4 cylinders are present. Only the drawback of this type of cylinder engine arrangement is that the size of the engine becomes huge. In this diagram, this is the 4 cylinder inline, 4 cylinder V type. The piston arrangement is shown here, and this is in case of 3 or 4 horizontally opposed cylinder engines. Generally in 4 cylinder engines the torque obtained as compared to the single cylinder engine is much more uniform, because 2 working strokes per revolution are obtained. The balancing is also better as compared to the single and double cylinder engines. And apart from this, the maintenance is also easier as compared to the engine with the larger number of cylinder. So let's discuss about first one, that is inline vertical type. This is perhaps the most popular engine for ordinary cars of medium size. It has a power impulse every 180 degrees of crankshaft rotation. So after 180 degrees the power stroke is obtained, means where we get maximum amount of power after compression stroke. The 4 cylinders are all in line. The second and third cylinder are in phase, while cylinder 1 and 4 are also in phase, but in the direction opposite to 2 and 3. So you observe that second and third, these are inline, these are moving in same time, and 1 and 4 are same. 1 and 4 are different with compared with the second and third one. Then we'll discuss about V type 4-cylinder engine. And the angle between two cylinders banks is usually from 15 to 20 degrees. That is 15 to 20 degrees. Thus the width of the cylinder block remains almost the same as in the case of inline type. This gives a more compact engine. The angle of V is kept small in this case because with larger angle the balancing of engine becomes more difficult. So that has to be considered while designing the 4-cylinder V-type engine. So here we will discuss about horizontally opposed. Generally we are talking about 4-cylinder engines. The picture represents the 3-cylinder engine. So in case of 3 and 4-cylinder engines, horizontally opposed type of arrangements are possible. So this type is similar to construction to the 2-cylinder opposed type. Rather, it has advantage over the 2-cylinder type that in this perfect balance is possible. If we compare it with the 2-cylinder engine, the balancing is very good, and even a rocking couple is also balanced. Its dynamic balance is even somewhat better than inline 4-cylinder engine, this one. So all these are about 4-cylinder engine, inline, V-type, and horizontally opposed. In next slide we will discuss about 6-cylinder engines and 8-cylinder engines. For higher horsepower and smoothness torques, the 6 and 8-cylinder engines have been used. So both for higher torque and smoothness, 6-cylinder and 8-cylinder engines are used. Like the 4-cylinder engines, they have also been designed in the form of inline, V-type, and opposed type configuration. So if we compare it with 4-cylinder engines, so similar kind of arrangements we can obtain in case of 6 and 8-cylinder engines. Whereas out of 6-cylinder engine types, the inline type is most widely used. In case of 8-cylinder engines, it is the V type which is almost universally in use. In 6-cylinder inline engine, there is power impulse every 120 degrees of crankshaft rotation. For heavy diesel engines, there are 7 main journal bearings to support the crankshaft, whereas the petrol engine usually have a 5 or even 4 main bearings. The angle between cylinder banks in V engine is generally kept 90 degrees. V8 type engine is of 2 types, with a single plain crankshaft type and 2 plain or cruciform crankshaft type. In the first one, in the second, the former, the crankshaft has 4 crank pin paired so that both outer and inner crank pins are in phase. So the main advantage of V8 engine are overall length of engine decreases. Then with the 90 degrees V angle, good engine balance may be achieved. Even firing intervals are obtained. Simple construction than the inline type. But the disadvantage are that more elaborate intake manifold is required from a central carburetor. V engines are also more costly to manufacture because of increased surfaces required to be machined. Generally V8 engines with the this 8-cylinder engines V type, these are with a smaller V angles, say 20 degrees, have also been made. Advantage of narrow V are less torsional vibrations and increased stiffness. However, the valve operating mechanism is complicated in case of 8-cylinder engines. So all these are about 6-cylinder and 8-cylinder arrangements, as we have discussed that if we compare it with 4-cylinder. Similarly, inline or horizontally opposed engines and V-type are possible in the case of 6 and 8-cylinder engines. Then next is radial engine. So as it is observed, it is clear from the picture itself that a single crankshaft which gives power with the help of the connecting rod to the many number of the pistons at a same time. So this is called a radial engine. In this case, the various cylinders are arranged in radial directions. So here 5 cylinders are shown. So radial direction is shown here about the crankshaft, which is placed at the center. The number of cylinders generally used is odd, like it may be 5 as it is shown in this Jiffy video, or it may be 7, 9, etc. to obtain uniform firing interval. This type of engine is compact and gives higher brake horsepower, weight ratio. The construction is also very simpler. However, this engine has a very large frontal area which create difficulty in streamlining the vehicle shape. Only in the case of the large frontal area that difficulty is considered. So if we recall all those type of engines once again, so we have discussed that single cylinder engine which develops more power. Then there are 2-cylinder engines having subtypes inline, vertical, V-type and opposed type. Then 3-cylinder engines. 4-cylinder engines again are having inline, vertical, V-type and opposed type. Similar subtypes we obtain in case of 6 and 8-cylinder engines for very smooth operation of the engine. And lastly, there is one type, radial engine. So one by one I will change this slide. It will be clear about all the engines. It will be for revision. So see the single cylinder engine, how does that power is developed in the 4-stroke engine. Only single cylinder is used to obtain the power that is restricted to 500 to 600 cc, that is the cubic centimeter, that is the capacity of the cylinder. Then 2-cylinder engine, that is inline. Then inline cylinder 180 degrees and this is for 270 degrees. This is the V-type 2-cylinder engine. Then this is the horizontally opposed type cylinder. This is the 2-cylinder engine. Then this is the arrangement of 3-cylinder engines in the cylinder block. So maximum amount of power is developed generally in case of Maruti 800 in India. If Maruti 800 has 3 cylinders, so 800 cc is divided by 3 for each cylinder. Then these are the 4-cylinder engines, like 4-cylinder inline, 4-cylinder V-type and 4-cylinder horizontally opposed. This is also shown for 3-cylinder horizontally opposed engine. Then we discuss about 6-cylinder engine and 8-cylinder engine, which has similar type of arrangement of cylinders, smooth operation. And then lastly, radial engine. It develops much more power in smoother manner. Only the frontal area is huge, otherwise very smooth operation is carried out in case of radial engine. So we have covered all the types and arrangement of the engine cylinders. Thank you. so much.